Okay. So with integration by parts, it's not easy to do a u sub on this guy. If I tried and made the u be the sine of x, then the problem is that the derivative of sine is cosine, and I don't have that. If I made the x the u, then the problem is I would still be dealing with this. So like, I mean, you might say that that might try it. All right, so u is equal to x, du is equal to dx. And now putting it in here, I have u sine of u du, which didn't get me anywhere, right? I mean, I'm still basically stuck where I am. Ryan, you're chewing gum. There's no gum in my class. You know better.
No, it was a cracker, I promise.
Okay, all right. So we can't use u sub on this, all right? And one thing that is universally true in u sub, sorry, in integration by parts is that you have a product, okay? And you know, you've got two things that you got to play with. Now, here's the way it works. So first of all, I'm going to do the very quick derivation of it, okay? So if I have, let's say I've got two things, u and v. So if I have u and v prime, okay, if I do the product of this, okay, first of all, if I take the product rule of this, this is the derivative of u, leave the v alone, leave the u alone, and then take the derivative of v. Okay, that's your product rule, old school stuff that you did a long time ago. Okay, so let's think about this. Let's put this back into Leibniz notation, and so we have d dx of uv is equal to du dx v plus u dv dx. Okay, so that's your Leibniz notation, and I'm just gonna wrap that guy in there. Okay, so what happens now is actually kind of really cool. This incremental step of dx is everywhere, so I'm just gonna go ahead and get rid of it. And now I'm going to integrate all three because they all contain a d of something, right? So the derivative, the integral of duv is just uv, and now I've got v, the integral of v du plus the integral of u dv. Okay, and we can't immediately integrate these because we really don't know what u and v are or what their derivatives are. But what's really quite cool right here, okay, is I can rearrange this. Running out of room. Second. Make sure not. Right. Where did I lost my page. Yeah. And we wind up with what happened? No, the integral of u dv is equal to uv minus the integral of v du. Okay, now the deal here is I take an integral that I can't normally deal with, and I can break it up into something that's not in an integral and something that I can maybe integrate itself. So here's the way it works. Let's take a simple example, the one I had before. And the way I deal with this is just using a very simple little tool, little grid. Now, one of your things is going to go in this space. One of your things is going to go in this space. Okay? You are going to take derivatives this way. And you are going to take an integral that way. And one thing is going to go here. And one thing is going to go here. And you're going to fill in all of these squares. So here's the deal. I want to put something in this red box so that when I take a derivative of it, it's very simple. I don't want to make this get worse. I want the derivative to become simple. Which of these two functions would be the easy thing to take a derivative of and make it go simpler?
X.
Now, the derivative of x is just 1. The other guy is going to go in here. Now, what's the integral of sine?
Cosine.
Say it again.
Negative cosine.
Negative cosine. Okay. Once you've filled in this box, here's how you write your answer. It's this minus that, or this minus the integral of that. So it's x times the negative cosine of x minus this. And obviously I can clean that up. And the integral of cosine is straightforward. And what's that? Guys, what's the integral of cosine?
Sine.
Thank you. See, those pauses make me wonder, do you really know? So just to make sure that we're not out of our minds, let's take a derivative of it. So if I take the derivative of this, I take the derivative of the first, which is -1, leave the second guy alone. Now I leave the first guy alone, and I take the derivative of that. The derivative of cosine is negative sine. And now the derivative of sine is cosine. And I get negative cosine of x plus x sine of x plus cosine of x, and those cancel, leaving me just x sine of x, which is what I started with. All right, let's do some more. Okay. So both of these are easy to take a derivative of, but one of them goes away, and that's what's better. Picking the thing that disappears is easiest, and the other guy goes here. So the derivative of x is 1, and the integral of e to the x is e to the x. And we write this minus the integral of that. and we're done. Okay, now sometimes, and quite often actually, there's going to be some constants that spit out at you. So be aware of those. Let's do okay. X and 1. And this would be the sine of 3x and a 1/3. Please convince yourself that that's what the integral of cosine of 3x is. Because you're going to have the product rule in there. The derivative of sine is cosine, and then the derivative of the stuff inside is a 3, so I need a 1/3. Okay? So your answer is x over 3 sine of 3x minus the integral of 1/3 sine of 3x dx. And now we got to do that integral. And the integral of sine is negative cosine. And then I need the reciprocal. And now we can clean that up. And we're done. That's a 9. How do we feel about this process? Okay. Okay, so I'm going to take the thing that is the easy thing to take a derivative of and use it up top. And the derivative of x squared is 2x e to the negative x. And now when I integrate that, I get itself. And then the reciprocal of the derivative, which is still a negative 1. So now, this minus the integral of that. And now we can clean that up. Okay, and now all we got to do is integrate that. So how do we do that?
Same thing.
Yeah, we have to do integration by parts again. Now, do not lose your coefficients. It's a great way to screw this up. So it's this minus the integral of that. How does that work? Okay, you're going to try this one on your own. Okay. So now I have negative 2x cosine x over 2 minus the integral of negative 2 and do yourself a favor, don't deal with all these constants in the middle steps. It's a great way to blow it up. Just do it at the end. It'll look messy, but rather than doing it in the middle steps, you'll only have one. If you have to do it in layers, do it in layers. And the integral of cosine of x over 2 is 2 sine of x over 2. How did that work? Who got screwed up with the integral of sine of 1/2 or the integral of cosine of x over 2? It's common. It's a common way to blow it up, okay? Just remember, the derivative of what gives me cosine? Okay, so the derivative of sine gives me cosine. And then I need to get rid of the 1/2, so it's the reciprocal of that. Okay? All right. Now, where's my notes? I had notes. Well, first of all, make sure you're still good. Okay. So what if I gave you no, don't do it. Don't write it. Don't copy. Well, you can copy it, but don't try and solve it. Okay. Do you think that this is going to take a while? Because what are you going to have to do? Every time you do an integration by parts, it's going to knock this guy down one derivative, right? The first time you do it, it's going to go, it's going to look like, x to the 5th, x5, x to the 4th. And then the next time you'll have an x to the 4th and an x to the 3rd, x to the 3rd, x to the 2nd, and so on and so on and so on. You'd have to do this 5 times, right? And that just kind of sucks. So when you have this kind of a thing where this can be destroyed, and this guy cycles, when you have this kind of a situation, now remember, when I say cycles, I mean like derivative of cosine, integral of cosine is negative sine, which then goes to cosine again, and then, negative cosine, and so on and so forth. It cycles in that pattern of 4 that we've talked about before. Okay, things that cycle are sine, cosine, and exponentials, and other bases. Those are things that cycle because they always spit themselves out, or they spit a variety of themselves out, and eventually they come back to themselves. Okay, that's what I mean. Then you're going to use this technique, and I'm going to show you how to do this real quick. You're going to make a table, and here's what the table looks like. you're going to put the thing that gets that you take a derivative here. You're going to put the thing that you do an integral over here. And this is going to be plus or minus signs. And here's what I mean. You're going to start off with x to the 5th. And you're going to do the thing that you integrate. Now, this is going to alternate between positive, negative, positive, negative, positive, negative. And it's important that you know that the very first step is a positive. Now what you're going to do is you're going to cycle down through these. So the derivative of x to the 5th is 5x to the 4th. The integral of cosine of 2x is 1/2 sorry, that's a positive. Sine of 2x. And now we do it again. But remember, there's a 5 out here, so we can't lose that. And now I take another integral. So that's negative cosine of 2x. And now this becomes a 1/4. And now we keep going. So this is 20 and a 3. So now this is 60. And now this is negative, cosine is negative sine. So this is positive again, right? This is negative still. And this is 1/8. Oh, darn it. Sine 2x and a negative. 120x. 1/16 cosine of 2x. And now just 120, 1/32 sine 2x and a negative. Now here's the deal. You got to go a little further. So this guy, when you're done with your x's, you're done. This guy's got to go one more step, and this guy's got to go one more step after that. Because here's your answer. And your final answer is everything on this line. So x over 5 over 2, x to the 5th of 5 over 2, sine of 2x times a positive 1, right? Now on this next one, we've got a negative and a negative, a 5 and a 1/4, excuse me. So the negative and the negative, the 5 and the 1/4, x to the 4th cosine of 2x. And now I've got a positive, a negative, and a 20, and an 8. So the 4 and the 8 are going to reduce, and I get 5 halves. And it's a negative, because it's a positive and a negative. Now I've got a negative, a 1/16, and a 60.
Mr. Ronco,
Yeah.
on that last step, wouldn't it be plus because the 1/8 sine 2x is negative? So if you...
Right, but it's a positive times a negative.
Okay.
Which gives me the negative.
Okay.
Okay, cool. Now here I've got a negative times a positive and a positive. And I've got a 1/16 and a 60. They both contain a 4. So this gives me 5/4. And I have an x squared. And I have a cosine of 2x. And then second to last, a positive and a positive and a positive. And now I have, that is going to give me, I can pull out an 8. So that's going to give me 15/4. A single x and a sine of 2x. And then finally, a negative and a negative, the 120 and a 64 is going to give me a positive 15/8 cosine of 2x plus c.
On the x squared term, shouldn't it be negative 15/4? Oh, it's 60 over
Pick
16.
me to death on this. All right, hold on. 3 on the cubed,
Squared.
on the squared. So 60 pulling out, it should be 15/4. All right, yeah. Ritvik, there's a finger gesture that I'm thinking of. All right. Okay, so do you see this pattern, people? Okay. Now, you try. I won't make it as nasty. Let's just do x over 2 dx.
Mr. Rongo,
Speak to me.
for like the plus and minus side, do we always start with the plus sign? Or?
Always.
Okay.
Always start with a plus.
All right, thank you.
Sure, man. How'd that feel? Okay. Okay, cool. So let's talk about, we're doing better on time than I thought we were, which is great. Which means we might actually get to everything today, which is going to be awesome. All right, let's talk about some cases that pop up from time to time. Okay, and we'll just do a simple, easy one. Okay, now this is going to be a little different because now what we're talking about are two things that cycle. Okay, so let's just for a second just see what happens. Okay, well, you see the problem with doing the table method on this one is that the guy on the left-hand side of that column that you take derivatives and derivatives and derivatives of, they're just going to keep on going, right? They're never going to stop because they cycle. So when you have two things that cycle, the table method doesn't work, okay? So what you have to do instead is churn through it once or twice and see what happens, and you'll see that something really cool happens, okay? So here's the deal. Since they both cycle, I really don't care who goes up top or down below. So I'm just going to pick one, okay? I'll put the trig up here. Now, here's the thing. If you do this, it doesn't matter who you do, okay? It'll work out either way, all right? So the derivative of sine is cosine. The integral of e to the x is e to the x. And now it's e to the x sine of x minus the integral of e to the x cosine of x dx. Okay, and you might be saying, Ronco, we're going to be spinning wheels here in a minute. So I'm just going to do it again. Derivative of cosine is negative sine. E to the x, e to the x. I am not out of my mind. This is not for no reason. So now I'm running out of room here, so I'm going to do it over here. Give myself a little more room. And now it's this minus the integral of that. And since I've got a negative, it becomes a positive. And just for giggles, and you're like, Ronco, what are you doing? This is just going to keep on going forever. Except, if you'll notice, we got where we started from, right? That's what this is. So, if we look very carefully, you don't have to write this step, but you'll see it in a second. Just, I want to put it all on one piece of paper, okay? That's where we are, right? That is the same as that. combine like terms. And then divide by 2. And that's the answer. To me, that's pretty sneaky. Come on. Aren't you impressed? I'm impressed. That's cool stuff. That's not the kind of thing that you normally think about doing, right? You normally just are like, yeah, I'm just going to keep burning through the problem. Rah, 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 rah. You know, bull in a china shop, bang, 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 bang against the math problem. Okay? But that doesn't work. Instead, you've got the same thing on both sides. Bring it over here and then divide by 2. So let's try one. You'll try one. And here's the thing. Just call this I for the integral, okay? And solve for I at the end of the day. So let's do e to the negative x cosine of 2x dx. Now be careful, you're going to be spitting out coefficients, right? Don't lose them. You need them. By the way, people, there's one thing I need to make sure you do. Who chose, what did you guys choose to put up here? The cosine or the exponential?
I put the exponential.
I put the cosine.
The cosine.
Okay, I don't care. But when you do it again, like if you're going to put the exponential up here, you can't put the exponential down here, because what's going to wind up happening is they're going to wind up undoing each other. Stick, you know, there's an old expression, stick with the girl you came with, right? Dance with the girl you came with. If you're going to put an exponential here, you're going to put an exponential here. Don't change it up in the middle of the problem. If you start with a trig, you start with a trig. How we doing? Give me a thumbs up when you're done. Okay, what part of this was not pleasant? Or were you just okay? Soham, are you suffering in silence? Okay. Stephen is plotting my demise. He's organizing a brute squad. All right. Okay. All right. Are we feeling like we can try something a little different or? Okay. Huh. Now, taking a derivative of a natural log is pretty straightforward. But taking the integral of a natural log, that's not anywhere on our lists, anywhere. Okay. So what we can do is we can use integration by parts. But my question is, what do we put where? Ritvik, don't say a word.
Maybe x to the 0th.
The problem, well, where? Where?
Uh,
Top
Probably.
left, bottom right.
bottom right, probably.
Okay, so if I put, what's x to the 0th then?
1.
And that would mean I would put the natural log here, right?
Yeah,
What's the derivative of the natural log?
over x.
And what's the integral of that?
X.
See that?
Well, I got lucky.
Good call. Finish it up. How do you feel? Let's see how sneaky you are. If you need to use your formula sheet, use your formula sheet. But we all know, I think we all know, the integral of what is the arctangent of x?
One over one plus x squared.
Right.
Can we just U sub this?
Yes, you can. How's that feel? So, there's no crying in calculus. Okay. So, we're going to be using this method for a while. Okay. It's going to become a tool that's in our toolbox. Show of hands, who got a textbook from the school already?
I kept my textbook from last year.
Oh, snap.
It's just the textbook from last year, isn't it?
Yeah. That's my fault.
Yeah, then I have that.
You know why? You know why it's my fault? Because I told the HL1s. I forgot to tell the HL2s. Oh, that's okay. Everyone's going to kill me now. But here's what you got to do. There are two ways that we can do this, that you can get the textbook. Thursday from 5 to 7 in the auditorium, or 8 to 4 Thursday or Friday. And what if you come by between 8 and 4 Thursday or Friday, you're going to have to pick it up from Miss Hodgson, who at this point is going to kill me because I forgot to tell my entire class. So, yes, she will. There are medieval torture devices that I'm sure she can come up with. Yes, and yeah. Dude, that stinks. Oh well, I'm sorry. Okay, but you need to get a book. Okay, we're going to be using it for the whole year. If you want, go ahead and if you want to turn back in your old book to her, that's fine. Or you can hold on to it until we come back into the building, provided that we come back into the building ever. Okay.
Oh, so it's a different textbook?
Yeah, it is. It's a new one because of the new standards. And it's specific to IB. And it looks like that. And I'm going to be assigning homework out of it. It's not a big book. It's pretty thin. It's about an inch. Okay. So here's your homework. Like I said, y'all are going to frickin' kill me. All right, let's see if we can pull this off. Wait a minute. I don't know. Can you take a screenshot? Let me see if we can do this.
I think I can.
Okay. Here are your problems. Wait a minute.
It's like blurry, so it's.
Yeah, it's way
Oh
too
my
blurry.
God. Rich Vic, your speaking privileges. Hold on. Let's see if I can do this.
Can you just send us an email?
Oh,
Yeah, with the picture of it or something.
y'all are going to make me work for this. All right. Y'all, oh my God. All right. I will do this. I will fix this problem. But you guys need to go and get a book either tomorrow. You can go today. Is anyone going to go today?
What time?
Until 4.
Where would we go?
Let me see if Miss Hodgson is even in her office.
Can someone else, do we have to be there to get it, or can someone get one for us?
I don't care if somebody gets it for you. That's not a problem.
Okay.
All right. I will email her. She is in her office. Thank God. All right. I'm going to email her now. Okay. I am emailing her now, telling her that to keep, what is it, 13 copies of this book or 14 copies of this book?
Does it
14
be there
copies.
today?
What's that?
So it should be there today.
Well, if you can do it today, do it today.
I'm gonna go there.
But all right, show of hands, who's coming today? 1, 2, 3, 4, at least 4. All right, who's going tomorrow? Who's going to go on
I'll probably
Friday?
go tomorrow.
What's that?
Oh, do we need anything with us, like our student ID?
I think Ms. Hodgson knows you. But, bring your student ID or at least your student number. Your URHS number.
So we go into a room, into the building, into a room to get in?
Yeah, unless you go on Thursday and then you go to the auditorium.
Okay, yeah. And do we have to give back our old one?
If you want to, do me a favor. Let's do this. Don't. I don't want her having to haul all of your old books, which weigh a frickin' ton, all around the place. Okay, so just hold on to that. Hold on to your old textbook. I might one day throw something out of it at you.
Wait, Ben, don't you own it? Don't you have it?
Me?
You picked it up for like $5 in the case.
Oh yeah. They're nothing, dude. They're like ridiculously cheap. I mean, like, you know, yeah, definitely. They're worth very, very little. They're like on, I think like that's the 9th edition and they're on like the 35th or something by now. So yeah, no, they're not excitingly fantastic, expensive books, but they still belong to the county. So eventually one day I'd like you to return them, but let's worry about that, you know, either in person or at the end of the school year when you turn in everything else. Okay. All right. I will send you a picture of these problems, and please, please pick up a copy of the book sometime in the next 3 days.
So we have until 4 today?
Yes.
Okay.
All right. Sorry about the rush. My fault. I suck. Don't worry. Miss Hodgson will, you know, throw something hard and fast at me. So we're good. Okay? All right. Take care, everybody. Check your email in a little while. You'll have the assignment. All right? Have a good day.
Thank you.
See ya.